Good afternoon, distinguished colleagues. It's a pleasure to be here today. My name is Naydenova, and I'm a PhD student at the University of Telecommunication and Post in Sofia, Bulgaria. Today, I'm pleased to present my research entitled A System Engineering Framework Supporting Roadmap Development Toward Lights-Out Manufacturing. Manufacturing is undergoing one of the most profound transformations in its history, driven by the rapid advances in artificial intelligence, the industrial Internet of Things, cyber physical systems, and autonomous production technologies. As a result, lights-out manufacturing has evolved from a visionary concept into a realistic, strategic objective for modern manufacturing enterprises. Existing research had made remarkable progress in developing these technologies. However, despite these advances, one fundamental challenge remains. How can manufacturing enterprises systematically plan and manage their transition toward lights-out manufacturing? This question lies at the heart of this research I will present today. Rather than examining how this evolution occurs, it focuses on how it can be systematically planned and managed from a system engineering perspectives. Let us now look more closely at the challenge. Today, manufacturing enterprises have access to an unprecedented range of advanced technologies. Artificial intelligence, the industrial Internet of Things, cyber physical systems, and autonomous production technologies provide capabilities that only a decade ago seemed unattainable. In principle, these technologies should enable enterprises to move systematically toward lights-out manufacturing. However, this is rarely what happens in practice. Many enterprises successfully adopt individual technologies, implement pilot projects, and automate specific production processes. Yet, these initiatives often remain isolated, fragmented, and disconnected from one another. The challenge is not the availability of technologies. The challenge is the absence of systematic approach for planning and managing enterprise-wide transformation. Enterprises already pose many of the technology's building blocks. What is often missing is a systems engineering perspective that integrates these elements into a coherent and coordinated transition process. This observation leads directly to the central arguments of this research. Technology enables autonomy. System engineering enables transformation. This naturally raises another question. If this challenge is so evident, why hasn't it already been solved? To answer this question, I conducted a comprehensive review of the existing literature. The review revealed that existing research provides a substantial body of knowledge addressing different aspects of enterprises' transformation. We have advanced autonomous manufacturing technologies. We have maturity and readiness models. We have enterprise architecture models. We have digital transformation roadmaps. Each of these contributions is valuable. Each addresses an important part of this transition process. However, they remain largely disconnected. What is still missing is an integrated systems engineering framework that brings these elements together into a coherent approach for planning and managing the transition toward lights-out manufacturing. This is the research gap that's motivated the present study. Having identified this research gap, the next step used to determine how it could be addressed. This led to three questions that guide the development of the proposed framework. The first question, asks which enterprise transformation domains are essential for a successful transition toward lights-out manufacturing. The second question asks how can design domains be integrated into a system engineering framework? And the third question asks how can the framework support structured enterprise transformation planning? Together, these three questions lead to central thesis of this study. The transition toward lights-out manufacturing should be approached as an enterprise systems engineering problem rather than solely as a technology implementation challenge. To answer these research questions, a systematic methodological approach was required. The study adopts qualitatively conceptual research design grounded in systems engineering principles and theoretical synthesis. The research began with a comprehensive literature review covering lights-out manufacturing, Industry 5.0, systems engineering, enterprise transformation, and social technical systems. Building one of these foundation, an enterprise system analysis was conducted to identify the recurring strategical elements involved in the manufacturing transformation. These elements were then synthesized into the proposed system engineering frameworks. Rather than introducing entirely new concept, the framework integrates established knowledge into a coherent system engineering approach for enterprise transformation toward lights-out manufacturing. System engineering was chosen as the guiding discipline because it is specifically designed to manage complex multi-domain transformation rather than optimizing a single technical component in isolation. This makes it particularly well situated to a transition that spans technologies, organizational and human dimension simultaneously. Having established the methodological fundamentation, let me now present the proposed systems engineering framework. The central idea of this framework is that a manufacturing enterprises should be understood as an integrated, short technical system rather than as a collection of independent technologies. From this perspective, successful transition toward lights-out manufacturing requires coordinated transformation across 6 interconnected enterprise transformation domains. The organizational domain addresses governance, organizational structure, and strategic coordination. The production domain focuses on manufacturing processes and their evaluation toward autonomous operation. The technological domain includes artificial intelligence, the industrial Internet of Things, cyber-physical system, robotics, and enabling technologies. The informational domain concerns data, informational architecture, and communication across the enterprises. The human domain addresses the evolving role of people, competitions, and human-machine collaboration. The decision domain integrates strategic and operational decision-making throughout the transformation process. These domains should not be viewed independently. They continuously influence one another, making enterprise-wide coordination essential for successful transformation. To illustrate how these domains interact, consider the introduction of autonomous mobile robots on the shop floor. On the surface, this is a technological decision, yet it immediately raises organizational questions about supervision, human questions about operating roles must be redefined. Informational questions about the robot data feed into enterprise system, and decision questions about how approves change to production flow, a perspective that addresses only the technology domain would overlook all of these connected implementations. Once the enterprise is viewed through these 6 transformation domains, the next question becomes how this perspective can support the transition in praxis. The framework answers these questions through a structured roadmap development process. The progress begins with assessment. It continues with gap analysis. Based on the identified gaps, strategic planning is performed. The resulting decisions are translated into structured roadmap. The roadmap guides implementation. Finally, monitoring supports continuous evaluation and refinement. Rather than representing a linear project, this process supports continuous enterprise transformation to iterative planning and improvement. In the assessment stage, the current state of the enterprises is analyzed across all 6 transformation domains. Gap analysis then identified the specific distance between this current state and the enterprise transformation goals. Planning translates these findings into concrete strategic decisions, including defining the target state and prioritizing transformation actions, which are then structured into a roadmap, the central deliverable that guides implementation. Implementation is where the enterprise begins to execute the planned challenge, as monitoring ensures that progress is tracked so the roadmap can be adjusted as conditional involved. The proposed framework contributes to the existing body of knowledge in 3 complementary ways. First, it introduced a system engineering framework specifically designed to support enterprise transition toward lights-out manufacturing. Second, it defines 6 enterprise transformation domains that provide the analytical structure for the transformation, distinct from and complemented by the process logic that connects them. Third, an integrated assessment, gap analysis, planning, roadmap development, implementation, and monitoring into one coherent transformation process. Taken together, these contributions shift the discussion from technologies deployment toward enterprise-wide system engineering and coordinated the transformation planning. The framework is conceptual in nature and provides a foundational for future empirical validation, readiness assessment models, and decision support methodology. Allow me to conclude with 3 key messages. First, successful transition toward lights-out manufacturing requires coordinated enterprise transformation rather than isolated technology implementation. Second, systems engineering provides the perspective needed to integrate technological, organizational, informational, human production, and decision-related aspects into one coherent transformation process. Third, the proposed framework offers a structured foundation for roadmap development and future research in autonomous manufacturing transformation. If I were to summarize this study in a single sentence, it will be this. The transition toward lights-out manufacturing should be approached as an enterprise system engineering problem rather solely as a technological implementation challenge. Thank you for your attention.